Okay, welcome to 2.4, Real Zeros of Polynomial Functions. So your objective is I will be able to calculate the real zeros of a higher degree polynomial. And real, remember, means rational and irrational. So what we're not going to cover here in this video is our imaginary zeros. So just rational and irrational. So an example of rational one would be like 3 or -3 or even 2/3. And irrational would be the square root of 2 or 2 plus or minus the square root of 3. And actually we want to make this plus or minus also. All right, so these are rational, these are rational. All right, so before we get into that and how to do that, I want to go over a couple things with you. So fundamental connections for polynomial functions. The following statements are all equivalent. X equals 0 is a solution or root of the equation f of x. Right, so this is the form. We would say x equals some number, and that's a solution for f of x. That also means that when f of x is divided by x minus this number, the remainder must equal 0 if this number is a solution. Also, this number c is a 0 of the function, if all of these other things are true. This number, c, is an x-intercept, so where it crosses the x-axis, this function, this would be c, is a real number, so either rational or irrational. But if all this other stuff is true, this is true as well. And then x minus c is a factor of f of x. Okay, so it's a factor if all these other things are true, but also I especially want you to pay attention to when f of x is divided by x minus c, the remainder equals 0. That means it's a factor. All right, so that's a bunch of words right now. So let's look at an example. Okay, so if 5 is a 0 of f of x, what is true? So that's one of them that I've already put here. So let's get rid of that. Right, 5 is a 0 of f of x. So this is already saying c is a 0 of f of x. So we're saying that c is 5 in this case. And that's going to help us see the connections between all these others. So what this is asking, so use the fundamental connections to list 4 things that are true. Well, if 5 is the 0 of f of x, what else is true? Well, then x equals 5 is a solution. So if it's a 0, it's also a solution to f of x. There's one thing. We can just go down the list. Now, if x equals 5 is a solution to f of x, and 5 is a 0 of f of x, then when f of x is divided by x minus c, or in this case 5, the remainder equals 0. Okay, so these are things that you already know, but I want you to be able to actually make this connection between all 5 of these. So if we know that 5 is a solution, then we also know that 5 is a 0 of the function. Then we also know when f of x, when the function is divided by x minus 5, the remainder equals 0. Okay, so I'd like you to pause the video and write the next 2 here with 5 instead of c. And think about what it's saying, and then we're going to, when you're done writing them down, return to the video and we're going to discuss them. Okay, so this is what you should have come up with. I didn't write if c is a real number because 5 is a real number. So I decided, hey, if 5 is a real number, then it is an x-intercept of f of x. So all it's saying is that this function, whatever it is, we don't know what it does, but we do know that it goes through the x-axis at 5. We also know, I just changed this, I put in c again, that x minus 5 is a factor of f of x, right? Because all these other things are true. These really are connected, right? When f of x is divided by x minus 5, which is a factor of f of x, the remainder equals 0. So that should make sense. Let's look at something that's a factor, not of a polynomial, but if I know that 5 is a factor of the number 25, then when I divide them, it's going to divide evenly and leave no remainder, as opposed to 5 is not a factor of 23. When I go to divide these, I would have a remainder of 3. Okay, so it's only a factor if it equals 0, and we know that just from regular numbers, but the same is true with polynomials. All right, one more thing I need you to see. before we can get into actually finding our real zeros is synthetic division. And hopefully you've seen this one, at least one time before, but I gave you the steps here to remind you how to do it. So as long as you're dividing by a term that looks like x minus c, you can also use synthetic division, right, as opposed to long division is why it says also, because I pulled these from some notes. All right, so write the zero of the divisor outside in a bracket like this. Then write the coefficients of the dividend next to that. Leave space below and place a line. So our divisor is here. We're going to write 2, right? We don't want -2. It's in this form. This has a negative, so actually this is positive, this number here. If this was plus, then it would be a negative that goes in here because we're writing the actual 0 in here. So 2, and then I need to write all these other ones. Well, keep in mind that we need to leave a spot for every exponent in descending order. So I could also consider this 2x to the power of 4 minus 3x cubed, but I need the one that's squared also. So plus 0x squared plus 5x minus 1. Okay, because I want to make sure that there aren't any gaps like that I jump from the exponent of 3 to the exponent of 1. I need to put a 0 in there. So now I write all these coefficients. I have 2, -3, 0, 5, -1. Leave a space and draw a line. All right, bring down the first coefficient and place it below the line. So this is just going to go down here. Multiply the number in the box by the number below the line and place it under the second coefficient. So we're going to go 2 times 2 is 4, and we're going to put it right here. And then add the coefficient in number. So we're going to add these together, and I get 1. And then we just repeat. 2 times 1 is 2. I put it here. Add, I get 2. 2 times 2 is 4. Add, I get 9. And 2 times 9 is 18. Add, and I get 17. I'll still put that in there. All right, if we had done this long division wise, we would have seen that there is a remainder of 17. So now how I can write this answer is, this is the remainder, this is the constant, so 9, and then as I head to the left, the number before that, oops, I'm missing part of my notes here. I'll fix that on here. It should say that the number before that is your x term. So this is going to be 2x, and that's a positive, and this is going to be 1 x squared, so I'll just write x squared, and that's a positive, and then this will be 2x cubed. So we start with our constant, and then we go up by a degree each time. Okay, so, and since I have a remainder of 17, this is not a factor, so x minus 2 is not a factor. Okay, but we're going to use it for when they are factors, but I just wanted to point that out to make that connection. I'm also not going into long division in this video because for our purposes, we're just going to use synthetic division because we're always going to be dividing by factors in what we're trying to do. All right, so how can we use this? So all this information, how can we use it? So our first example here, find the function that has a degree of 3 and has the zeros -3, -2, and 2. So we've learned before that if it has a degree of 3, the most zeros it can have is 3. And since we're given those zeros, we can say, all right, well, this is just x plus 3, and this is x plus 2, and this is x minus 2. And then if we're going to, this is a linear factorization of the function, but most likely you're going to see that we are going to want to multiply all these together and then come up with the function in standard form. Okay. Also, this is example 2 here. Took some stuff out of these notes to try to make it shorter. So let's go ahead and multiply this together. So I get x squared plus 2x plus 3x plus 5. Some of you might be able to come up with a simplified quadratic in your head and add these in your head. Okay, then we need to multiply this times x minus 2. And let me show you a little technique that's helpful here. So if I go ahead and multiply everything by the x, I would get x cubed plus 5x squared, and I'll leave more space in your notes for you to have to work here. Plus 5x. Okay, and then rather than putting all these, now I'm going to have to multiply by -2. Rather than putting them over here, I'm going to put them below and line them up. It's going to make it easier to add them. So -2 times x squared is going to be -2x squared, and I'm going to put it below the 5x squared. Since we're going to be doing problems like this, I'm just showing you kind of an easier technique here. And then minus 10. Then, now when they're stacked like that, I can just add down. So x cubed plus 3x squared minus 5x minus 10. I just realized I had a mistake back up here. So this is actually a 6. Should have a 6 here because we did 3 times 2. Should give you a 6 here. 6 plus -10 is -4x. Okay, so that's how you would come up with a function if you're already given the zeros, because we know that if these are the zeros, then these are factors of the function, and then you can just multiply them all together. So now we want to use this for finding the real zeros of a function when it's not factorable, right? So what this is saying is when we have irrational zeros. That's really what it's saying. Because before we could just factor it and then we would find those real zeros. You can also find the rational zeros. You can also find the rational zeros by graphing the function in your calculator. And that's going to be the first step to doing this. So for this function here, what are my rational zeros? Well, I've graphed it in Desmos for you, but make sure you're able to do this on your calculator as well. So here we go. Here's a 0. But it's a decimal, and the decimal that you're seeing there is not the whole number. It's not the exact number. It's just a rounded off decimal. So what we're trying to do in this video is actually find out what that exact number would be. And that exact number is an irrational number. We're going to find that a little bit. First, I need my rational zero. So I have a -2 and a 2. Those are both my rational zeros. So let's head back over here. Find all your rational. We have -2 and 2. Synthetically divide by using the rational zeros. Well, since we know that the rational zero -2 is a 0, then we can divide by it because that would just be the same as factoring out x plus 2, right? So I'm going to put the 0 in and do synthetic division here. I'm going to get rid of this. All right, so I want to do synthetic division. That means that I have to make sure that I have all my exponents in descending order represented. So I have x to the power of 4. I do not have x to the power of 3, so I need to put in a 0 for that. I do have x to the power of 2. I do not have x to the power of 1, so I'm going to put in a 0 for that, and then my constant. Okay, by doing this, then you'll see all your zeros. It's a really common mistake to miss. Sorry, not all your zeros, but all your coefficients. So bring down 1, bring down 0, bring down -12, bring down 0, and bring down 32. Okay, we're going to synthetically divide here. So bring down the 1, and 1 times -2 is -2. Add them, I get -2. -2 times -2 is 4. Add these, I get -8. Multiply these, I get 16. Add these, I get 16. Multiply these, I get -32. And the remainder is 0. And that's what we want. We want a 0 here because that means that x plus 2 is a factor, and that's exactly what we're trying to do here. We're trying to factor this down until we can get it down to a quadratic. So synthetically divide using rational zeros to factor the polynomial until you're down to a quadratic. So I already used -2. Now I'm going to use 2. And I'm going to synthetically divide again. I would recommend you pause the video and try it yourself. If you don't come up with a 0 at the end, you messed up. You could have not used the correct rational 0, but we already looked for it, so we're sure that we do have the correct rational one. So you should end up with a 0 for your remainder. All right, bring down the 1. Okay, at this point, this would be your constant, so you have -8. This would be your x term, so plus 0x, and this would be x squared. All right, we actually don't need the 0x in there. We just have x squared minus 8. We now need to solve the quadratic to find the irrational zeros. Now, sometimes that's going to be using the quadratic function, not the quadratic function, the quadratic formula. Sometimes it's going to be completing the square. Sometimes it's just going to be extracting the square roots. It just depends on which method you want to use. So in this case, I'm just going to go ahead, set this equal to 0 and extract the square root. So I'm going to add 8 to both sides. And I take the square root and I have x equals plus or minus the square root of 8. All right, so what is my actual answer here? So that was just me solving here. So I'm kind of all over the place here, but what is the actual answer? Well, we were told to find the zeros. So our zeros are x equals -2, x equals 2, x equals positive square root 8, and x equals negative square root 8. That is our answer here. All right, what else can we use all this information for? All right, last thing that we can do, or that I want you to be able to do, is to write a linear factorization. So first thing you're going to have to do is find all the zeros. Well, we just did that. We found all the real zeros. When I show you how to find imaginary zeros, then we will find those as well. And then we'll have to write the linear factorization. But for now, let's just do it with these real zeros. And remember that when x equals c is a solution, then x minus c is a factor. So when I go to write this as a linear factorization, my -2 becomes x plus 2. My positive 2 becomes x minus 2. Then my positive square root of 8 becomes x minus square root of 8. And then I have x plus the square root of 8. I have now factored this equation using this system here. Okay, I've given you one problem to do. You're going to find all the real zeros of the function, and then you're going to write a linear factorization of the function. So you're going to do those last two things that I did there. All right, thanks for watching, and I will see you in class.